Hello students, in this video we'll discuss sketching cylinders. If we're given a relationship between exactly two of the variables x, y, and z, the resulting sketch in three-dimensional space is a cylinder. So let's see an example of this. So what I need to do is I need to give a relationship between two of the three variables, and the other variable will be free. The other variable is free. So let's see some examples of this. If I look at this relationship, x squared plus z squared is equal to 1, I could plot this relationship in the xz plane. Here's the x-axis. No, sorry, that's the x-axis. This will be the y-axis, and then this will be the z-axis. If I look at the xz plane, I see I have the unit circle in the xz plane. So this is the unit circle in the xz plane. So what I could do is I could put those points right here, and I could draw the unit circle. So I've drawn the unit circle in the xz plane. And now, this relationship is true no matter what the value of y is. So this is, as long as x squared plus z squared is equal to 1, y can be whatever it wants. Y is free in this problem. So for example, this corresponds, the circle I've drawn corresponds to y being equal to 0. I could have equally well drawn that circle with y being equal to 1. Let's say here's y equals 1. And then I'll draw the same unit circle in the xz plane. I'll just slide it over 1 unit down. That corresponds to y equals 1. I can draw the same circle at y equals something like -3. That's y equals -3. I'll draw the same circle in the xz plane. And I have this sequence of circles, all of whom satisfy the relationship x squared plus z squared is equal to 1, the unit circle in the xz plane, and I'm just sort of sliding them down along the y-axis. So the center of all these circles I'm drawing is a point on the y-axis, and I'm just basically drawing all those circles, pushing them down, and we can see we get an actual circular cylinder. So if I just connect all these dots, I will have a cylinder that goes on forever. The cylinder goes on forever in both directions. So this is going to be a circular cylinder, something we're used to from plane geometry. But now, in several variables, we can get more intricate cylinders. Here's another example. What we could do is we could look at the curve y equals z squared. Here in this problem, x is going to be the free variable. X is free to do whatever it wants here. And what we'll do is we'll draw the three-dimensional space. And z. And now in the yz plane, I know that y is equal to z squared. So what does y equal z squared look like? Well, it would look something like this. That parabola. And now, x is free to be whatever it likes, so this corresponds to x being equal to 0, but I can draw this parabola again when x is something like 1. So let's say that x is equal to 1 over here. I could draw the parabola again. When x is equal to, let's say, 0.5, I can draw the same parabola. X equals 0.5, draw the same parabola. I can also do x equals something like, let's say x equals -1. Draw the same parabola. And so what we see here is I have a whole sequence of parabolas whose vertex is sliding up and down the x-axis, right? And they're all exact identical copies to each other. So I'm forming a cylinder sort of shape which is open. Now the cylinder is open. it's not closed off, and every sort of slice of the cylinder is a parabola. And so if we connect these parabolas together, we have this region, this cylindrical region. All of the cross-sections of this region are going to be parabolas. We can keep drawing these parabolas over and over and over again. Connect the dots, and we get this parabolic cylinder. So this is going to be a parabolic cylinder. And basically, any function you have between any functional relationship between two variables, either x and y, y and z, or x and z, you can plot the corresponding curve in that plane and then extend that curve along straight lines to form a cylinder shape. And that's what a cylinder is in the multivariable calculus setting. Thank you very much.